Sackville!
Bit of a build-up. We'll see what happens. Okay, so without a doubt, my favourite Disney film has got to be Frozen. It's got great characters, it's got classic songs, and I've recently realised something that for me makes it even better. And that is the fact that Princess Elsa, our main Snow Queen character who sings "Let It Go," she is secretly a closet chemist. Now, she's probably not the first person you think of when you think chemist, but Elsa actually has an ability that many chemists would love to have, and that's the power of crystallization. So crystallization is the process of getting a solid crystal from a liquid. So for Elsa, that's getting crystals of ice from water. But as a chemist, I use it when I'm making a chemical. So I do most of my chemical reactions in solution, so they're in a liquid. And as you can imagine, this makes it quite difficult to separate stuff out. The product I want is dissolved in that liquid. And this is where crystallization comes in. If you can get your product into a solid crystal, it's then much easier to separate it out from the rest of the liquid. So the best way to think about how crystallization works is to imagine yourself in a crowded, cheesy club on a Friday night after a couple of drinks. So if the club itself is the liquid, and the people in it are the dissolved material that you want to crystallize, what you actually have in a club is ideal conditions for crystallization. Because you have, for crystallization, you need a supersaturated solution, which just means that you need a lot of the material that you want in not a lot of the liquid. Like a club, think moles, any Belf people here. You've got a lot of people and not much space at all, and sweaty walls, but that's not about crystallization. So you're in the club, you're making like Elsa, letting it go on the dance floor. No? And then suddenly you hear the beautiful introduction to that classic party tune, the Macarena. Now some people immediately start doing it until they look around them and they realise that no one else is joining in. And they kind of awkwardly stop. But if enough people around them join in, they have the confidence to go through the whole dance, and then before you know it, the people next to them are joining in, and then suddenly the whole club is doing the Macarena. That's great. Now, this basically is what happens during crystallization. You have points where crystallization starts, but if it doesn't build up to what's called a critical mass, you won't get crystal growth through the solution. The original crystal will just redissolve. Like Macarena, if you don't have enough people doing it, it won't spread through the club. Now, we've all got that one friend, maybe more, who they think they're cool, they're maybe a little bit hipster, probably have a beard, and they would not be seen dead doing the Macarena because, you know, they like a gypsy folk electro swing. If you find yourself in a club with them and the Macarena comes on, there is no way they're going to be joining in. And they will find themselves stuck in the throng of people doing the Macarena, and they probably won't be able to get out, which is, I don't know, karma. To compare this back to our crystallizing solution, those people that are stuck in the Macarena are like impurities. So you can end up with impurities that are not of the same material but are still in your crystal structure. And this can sometimes be a good thing. So a lot of precious gems that you have, like rubies and sapphires, have that colour because of impurities. But when I do crystallization, I usually use it for a purification purpose, so to have that impurity in there really isn't a good idea. So the next thing we're going to do is a little bit of a demo. You can probably guess what it's going to be. So everybody stand up, please. There's not a lot of space in here, so this is going to be really interesting, and you're going to get to know each other a lot better. So what we're going to do is we're going to do the Macarena, and we're going to do it just once round, and I'm going to sing. You can join in if you like. Okay, on the count of 3. 1, 2, 3. Da, 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 Macarena, Macarena, da, 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 Macarena. Okay, right, so that's fine. Everyone can sit down again. Beautifully done, beautifully done. Now, what you will have noticed then is when you directions. This happens in a club, obviously, and you end up with groups of people that are doing the Macarena in full swing. They've got over that critical mass bit, but they do that rotation in a different order, or they started doing it facing in a different order, which means that you end up with groups of people doing the same dance at the same time, but in a different order. So when this happens in a crystallizing solution, you end up with crystals that are made of the same material, but have a different orientation in space. And these are what's known as polymorphs. So something you're probably going to need your morning after the night in the club is some paracetamol. And paracetamol has two polymorphs. And those polymorphs will have different properties. So they will have different, they will dissolve in different ways. And that will then affect how quickly the drug enters your system and how quickly it affects you. So actually it's something that's quite important to be able to control for chemists. But it's this power that Princess Elsa has. She has the ability to make everyone in the club, including the hipsters, dance the Macarena in sync. One more time. Hey, Macarena, aye!